Hi guys, this is going to be the second lecture in Module 1. We're still in Introduction to Networking, but right now we're just going to look very quickly, and I do mean quickly, at the 7-layer OSI model. We're going to start with the application layer and just go through all 7 layers, and then that should take care of everything that we need to take care of as far as the OSI model is concerned. Now, does that replace the need for you to read the content? No, it does not. You still need to read the material in your textbook. Go through the slides that we're using. I'm going to kind of go through them, but you need to go back through them and look at the information. But for the most part, I'm going to try to hit the high points and give you the things that you need for the quizzes. So let's get started. Okay, here we are. Layer 7, the application layer, describes the interface between two applications on separate computers. Basically, you fall into two categories. Provides services like a web browser or email program, things like that. Think programs, think applications. Or utility programs that provide services like simple network management protocol, giving you the ability to log into a router remotely or giving you the ability to control things remotely on the internet. Payload is the data that's passed between the applications and the operating system. So when you're dealing with payload, if you're talking about a web browser, that would be the web page or whatever is being, whatever the result of the program is. Layer 6, responsible for reformatting, compressing, and or encrypting data. This is where data encryption occurs. It's very important. An email message, for example, can be encrypted depending upon what protocols that you're using. Those protocols, those encryption protocols, TLS and things like that, they're going to be in the presentation layer. Layer 5, the session layer, this is how data between applications is synced and recovered. So if the message didn't arrive intact, not all the packets arrived, then a TCP message, transfer control protocol message, will continue to wait until all the packets are there. Basically what it does is each packet is labeled with a number, and if those numbers aren't synchronized all the way through the message, then the TCP protocol knows that that message is not complete, and so it will go back and look through the packets, find what's missing. Most tasks are performed by the operating system when an application takes an API call, which automated programming interface. We'll talk about that a little later. The API, application programming interface rather, is a method an application uses when it makes a request to the OS. So if you've ever used a program where you could write your own scripts, sometimes video games are like that. Not quite a mod, but you can write your own scripts to automate processes and functions. What it's doing is it's making API calls, and so that's the sessions layer. Transport layer, basically there are two main transport layer protocols, TCP, that's transmission control, and UDP, that's user datagram protocol. Now, the difference is TCP makes connections and checks whether the data was received. We just talked about that. It looks at the packets and makes sure all the packets are there, and if not, it has error handling. It will go back and find the correct packets. UDP, on the other hand, is a lot faster, but it does not guarantee that all the pieces have arrived, and so UDP is not reliable. You wouldn't want to use a UDP message if you're sending things that it's absolutely important that all the pieces get there. Encapsulation, that's where we're making packets out of the data. It's the process of adding a header to the data inherited from the layer above, and basically what the header does is it says this is the port it needs to go to, this is the number, the packet number that this is, and so it breaks it into, the TCP program breaks it into small segments, sends those segments out, and basically what happens is they get collected by the receiver, whatever client is the receiver of the message, and then the TCP protocol checks to make sure that all the pieces of the message arrive safely. Network layer is responsible for moving messages. This is where you'll find the IP protocol, and this is also where IP network addresses live. There are two different types of IP addresses we're going to look at, version 4 and version 6. In case you're curious, we started out with version 4. Unfortunately, because that is a limited, or it is more limited, it's an 8-bit binary number, which we'll learn how to convert from binary to base 10 numbers a little bit later. But regardless, it's a limited, a very limited and a very small section of addresses or selection of addresses. And so we're running out of them. That's the problem that we're having right now. That's why we have an IP version 6, because IP version 4 is running out of numbers very fast. In fact, technically, it's already out of numbers. We're using subnetting to control that, but that's a stopgap at best. So, two different kinds of IP addresses, IPv4 and IPv6. The IP protocol in this network layer will divide large packets into smaller packets by fragmentation. We'll talk about what that means a little bit later. Layer 2, the data link layer. Layers 1 and 2 are responsible for interfacing with the physical hardware. So basically, this is where the drivers for your physical devices, this is where the protocols for sending a message on a network cable, this is where the hardware lives. Particularly layer 1 is the hardware layer. And so that's where any information about the network cables, fiber optics, things like that. In layer 2, we have the MAC address. That's the media control address. Every hardware device that's connectable to a network has a physical address built into it. MAC addresses, if you look in your computer's network settings, you can find the MAC address. It's different from an IP address, but it can be used for kind of the same things. It's built into the network card of your computer. You can spoof it, but you can't really change it. Let's put it that way. So, and then finally, layer 1, the physical layer. This is where the bits, this is where the actual binary numbers move along network cables. It can go through the air, as in Wi-Fi. It can go through copper, or it can go through fiber optic cabling. Those are three main medias for the physical layer. But that is basically what we're talking about when we talk about the physical pieces of the network. They live in layer 1, the physical layer. So we're not going to go through these protocols very in detail. You can do that. Combination of reading in your textbook and also looking through these slides. I'm just going to kind of roll through them. You will need to understand how the layers work and what pieces of the puzzles, pieces of the network, live in what layers, and how, like the header information and the tail information inside each packet, how it identifies the packet and what message it goes to. Which OSI layer adds both a header and a tail? Well, that would be the data link layer. That would be the data link layer puts its control information into a header, but also attaches control information to the end of the packet as a trailer. So basically, all the other ones are just adding header information or adding frame information. The OSI data link layer adds a header and a trailer. All right, we're not going to go through, well, yeah, let's go ahead and hit safety really fast. We're not going to talk a lot about it. Once again, you can read in your book. You will need to pass the safety exam a little bit later. Now, to get you to clarify, this is not the same safety exam that you had to take the first week of class. Most of you should have that one already done. And this is not that kind of safety exam. This is a lab safety and a office safety exam. This is safety procedures that you would probably see in an office. That first one, as you probably know, was a campus safety, what to do in case of an active shooter, what to do in case of a fire or tornado or things like that. So this is a different safety exam from that, but you will need to answer these questions. So these are office and lab safety requirements. We're going to look at those just really quickly. You need to know the procedures. You need to know how to use a fire extinguisher. You need to know how to shut the power off. You need to know what an SDS or material safety data sheet is. And essentially what that does is it tells you how to counteract whatever chemicals or solvents, things like that you're going to find. OSHA, I'm not going to ask you to know the OSHA regulations. That's completely unnecessary. But what you do need to know is that OSHA, the Occupational Safe and Healthy Administration, is the government branch that controls safety in the workplace. You will have personal protective equipment probably in any office environment you go to. At the very least, you should have safety glasses. Safety glasses are important, particularly when we start cutting making network cables and we're cutting those tiny little thin pieces of wire, that's the best way I know of to get blinded, is to end up with a little tiny piece of that wire in your eye. So we're going to wear safety glasses. All tools should be kept in good condition. If it's supposed to be sharp, it needs to be sharp and it needs to be properly stored. Use the right tool for the job. Not every tool is a screwdriver, and not every job requires a screwdriver. Also, watch out for trip hazards. When you walk, particularly if you're carrying something like a computer or something moderately heavy, walk on purpose. Look where you're going and go from one place to another. Don't meander. Don't stop to talk. Lifting heavy objects. Everybody knows this, or should. You lift with your legs. Make sure that the load is balanced. Keep your feet shoulder width apart. Keep your back straight. Don't bend your back when you're lifting. Use your knees and your hips and lift with your legs and shoulders, not your back and stomach, because the back and stomach muscles, once you damage those, they stay damaged. Keep the load close to your body and do not twist. You'd be surprised how easy it is to throw your back out just turning a little bit with a not very heavy load, but because your body's not used to it, that's a good way to get hurt. Keep the objects down as low as possible. Keep your back as straight as possible and just lift with bending your knees. Static guards. This is not so much to protect you, but it is to protect very expensive equipment. If you are a technician, you are working on someone else's computer, and because of your inattention to detail, you fry their processor because you weren't wearing a static strap or you weren't standing on the right mat. It's your responsibility, and it's also financially your responsibility. You get to buy them another $1,500 gaming processor, so let's be careful with the electronic equipment. Computer components are grounded inside the case. Grounding means that the device is connected to the earth. That means that everything on the motherboard is grounded to the frame of the computer. Now, sensitive components like processors and RAM and video cards and things like that can be damaged by the static charge that your body stores. So what you have to do is bring yourself to the same ground level as the computer. You can do that by wearing a static strap. You can do it by standing on a grounded static mat. Or you can also, it can be just as simple as touching the frame of the computer, the metal, the aluminum part of the case. Just make sure that you are at the same ground level as whatever component you're working on. So here's the things you can do. Number one, an ESD strap is a strap that goes around your wrist and it plugs into or clips to the chassis of the computer. Basically, that connects you to the computer frame, and that makes you grounded at the same level as the parts that you're working on. Touch the case before touching any of the components inside. Touch the metal of the case. Don't touch the paint. Paint is an insulator, and so you're not helping yourself if you're touching painted part of the case. Touch the shiny part. And then always make sure when you're storing a component that you put it in an anti-static bag. These things will protect you. Now, this seems kind of foolish, but I've seen this happen before. Make sure you unplug the computer before you work on it. Not only does that protect you from destroying components, but the power supply in a computer, fairly high voltage, fairly high wattage, and it will, if not kill you, it can make you injure yourself really badly trying to get away from it. So make sure that you unplug what you're working on. Okay, the final part, 7 steps to troubleshooting. I want you to read these, figure them out on your own. I'm just going to mention them, and then we're going to call it a day. Step 1, identify the problem and its symptoms. That makes sense. But it's also the most important step, because if you're working on the wrong problem, you're not going to solve what the customer needs to have solved. So you need to identify what the real problem is. Establish a theory. I wonder what could be causing this. Well, the screen is dark. There's a couple of things. Maybe the monitor's burned out. Maybe the backlight system is burned out. Maybe it's not plugged in. I have made more money probably from that in my computer repair career than anything else. Somebody calls me, my computer won't work. What's wrong? Well, I don't know. It just won't come on. It's dead. Must be the power supply. I'm fixing to go buy a new power supply. Will you put it in? Let me look at it first. I walk in, I jiggle the case plug, and then I jiggle the wall plug, and I turn it on, and it fires right up. And that cost them $100, but it also saved them from going and buying a power supply they didn't need. So establish a theory, test the theory, jiggle the plug the cord in, see if that's what it is, unplug it, reboot the computer. There are a lot of things you can do to test. Once you've tested and established that your theory is correct, Then come up with a plan. How am I going to fix this? Do I need to buy parts? What do I need to do to make this right? And then work the plan, do only that, and then make sure that you verify functionality. This works. Nothing worse than fixing something, fixing it, watching it work the first time, and then turning it back in and say, well, hey, it quit working again. So you want to fully test. You want to over test. Implement full functionality and make sure that whatever you fixed is actually fixed. And then finally, most important, or second most importantly, document it. You want to keep notes. You want to write down what you did. Most companies will have a database and they'll have a trouble ticket system, and you'll have a form to fill out, or an online form to fill out. And basically, what that does is gives you a knowledge base to work from. We've got a specific program here, and this is what goes wrong with it most often. And then I've got a new guy that I have to train, and so now the new guy has all the experience that everybody else has because he's looked at the knowledge base and he knows, hey, I've got these same symptoms. I wonder if it could be that. Sure enough, it's that. So those are the 7 steps to troubleshooting. Now, self-assessment, you don't have to write this down, you don't have to turn this in, but do go through these questions and make sure that you understand what we just talked about in the last 2 lectures. Summary, basically this is what we learned in the last 2 lectures. Distinguish between peer-to-peer and client-server networks. We talked about that earlier the other day. Identify types of applications and protocols. We did that with the OSI model. Describe various networking hardware devices. We talked about routers and switches and network cables and repeaters and things like that. The 7 layers of the OSI model, we are going to go back through that again, not only in the reading but also in future classes. Best practices for safety. Remember, lift with your legs and use static protection whenever you can. And then finally, the 7 steps of troubleshooting for looking at network problems, or really any kind of computer problem. This is a good method for any kind of repair process. So if you are familiar with these 6 things, then you've got exactly what you needed to get from this module. Hopefully you'll go back through, read the chapter, and you'll maybe look at these notes again. Watch the lecture again. Like I said, I'm not going to go into detail during the lecture, but what I am going to do is kind of help you just hit the high points and point out things that, yes, this will be on the test, or no, this won't be on the test. So now you can go ahead and look at the chapter quizzes. Get those done, get those turned in. Remember, you can do the chapter quizzes as many times as you want, and we will only keep the highest grade. I'm doing my very best to make sure that the grades in this class are good. So it's on you now, because I'm doing everything I can to make them good. So it's on you to do what needs to be done, and I will see you at the next class period. Have a good day, guys.